Hi everybody, we're back for another fun video on inequalities. So today what we're going to be learning is absolute value inequalities. This is actually our honors topic, so if you're watching this video and you're not in honors, then go ahead and stop the video and do the other homework I gave you, okay? Now if you are in honors, keep watching the video. Alright, let's go ahead and get started. Vocab! Very, very big vocab. So our only vocab is to remind you what an absolute value is. So it is the distance any number is from 0 on the number line. Now, something to remember when we're doing this. Absolute values are, let's talk about vocab. The distance any number is from 0. So 0 is smack dab in the middle of our number line, which means it can have a distance in front of it or behind it. Okay? So like 3 is in front of it, and its absolute value is 3 because it's 3 units away from 0. Negative 3 is behind it, though. It is also 3 units away. That's why its absolute value is also 3. Okay? Just keep that in mind. Alright. Sorry it got wordy, but like solving an equation with absolute values, absolute value inequalities represents two different inequalities. Okay? Let's see if I can find the next part. There's gotta be another part. I think. Ooh, I don't even know anymore. Yeah, there's gotta be one. Oh, there's not. Okay, just kidding. Sorry. That made it long. Oh, this Scully is failing. Alright, this is the wordy part. Each absolute value inequality represents two situations that show the same distance away from 0. The first inequality, or the first situation, is an equality that is written as the same as what is given without the absolute value. So if we had the absolute value of like 2x is greater than 3, here's going to write 2x is greater than 3. So just lose the absolute value symbols and write it the way it is. The second inequality that represents the other direction for the distance is going to look like the first, but it's going to have the opposite inequality sign. So you're going to flip the inequality sign, and it's going to have the opposite sign of the number. So that 2x is greater than 3, the opposite sign would be less than, the opposite 3 would be negative 3. Okay? So you're doing a lot of opposites. Similar to with the equations. Okay? So, if the inequality sign is a less than or equal to, the absolute value inequality represents the compound inequality with the word and. So this is the extra inequality part. So if we have a less than or equal to symbol in our problem, the original problem, when we create our two inequalities, we're going to have the word and in between it. Okay? If the inequality sign is greater than or equal to in the original problem, the compound inequality is going to have the word or. Okay? Alright. So right now we're going to go ahead and try on our own to rewrite the absolute value inequality as a compound inequality. So looking at A, so we have a less than symbol. Remember, a less than symbol means it's an and statement. So our first inequality will look like, oh, I guess I did them both together. So the first one, I've got 8 minus x, because that's what's inside the absolute value. I'm going to drop that for that sign. I'm going to keep the less than symbol, and I'm going to keep the 2. For the second one, I'm going to keep what's inside the absolute value, 8 minus x. I'm going to flip the sign to be greater than, and I'm going to change this to be negative 2. Okay? So I just write it like that, and because it's an and statement, I need to put the word and in there, or I could just combine them into one big thing. Okay? But either one of these is acceptable. Alright, second one, I've got a greater than symbol. So greater than means I'm going to have an or statement. So that means I'm going to have 1 minus 2a is greater than 11, so keep everything the same, just lose the absolute value symbols. Or I can have 1 minus 2a is less than, because I flip this, negative 11, because I changed the sign. Okay? So this one you're going to try on your own. Okay? Take note that it's a less than or equal to symbol. What does that mean? And what is it going to look like? Okay? So go ahead and try this one on your own, and when you come back, if you probably didn't get done. When you come back, I'll have the answer. Okay, so less than or equal to means it's an and statement. So there we go. We have 4n minus 2 is less than or equal to 42. I just keep it the same. Everything's the same except the absolute value symbols are gone. And the other one is 4n minus 2. Flip my sign to be greater than or equal to, and change my 42 to be negative 42. Okay? So that's the first half. Once you do this, though, it's pretty easy. It's just like compound inequalities. You just solve them how you would at compound inequality. Okay? Let's try another one. So here we actually have to solve them. I've just got this little, I guess I can get rid of it. So I'm going to go ahead and do this. I'm going to do A, and you're going to do B on your own. So let's do A first. So we have the absolute value of 1 minus 2p is greater than or equal to 9. Well, greater than or equal to means it's an OR statement. So I'm going to split it. So I have 1 minus 2p is greater than or equal to 9, and then 1 minus 2p is less than or equal to negative 9. Okay? Now to solve this, I'm just going to go ahead and get p by itself. So first I need to subtract 1 from both sides here. That gives me negative 2p is greater than or equal to 8. Divide everything by negative 2. It's going to give you p is less than or equal to negative 4 because I had to flip the sign because I divided by negative. Here I'm going to subtract 1, which gives me negative 2p is less than or equal to negative 10. Divide by a negative again. That's going to give me p is greater than or equal to 5. And it's an OR statement, so I just write that in between. That's all I have to do. Okay, so honestly, the most difficult part about this is going from this one absolute value thing to making it into a compound inequality. Okay? So go ahead and try this one on your own. Alright? When you come back, I'll show you the answer. Okay? Good luck. Okay. So, we have 2 is less than the absolute value of negative 3k minus 2. You could leave it this way, or if you wanted to, you could flip it around to be the absolute value of negative 3k minus 2 is greater than 2. I just need to make sure that here it says that the absolute value is the greater number, so when I flip it around and have that in front, the sign needs to follow that as well. Okay? But now, when I flip it, it's a greater than symbol, so it's going to be an OR statement. So, and actually it does matter, you do need to flip it so you can determine what kind of symbol it is. Not, just kidding, you do need to flip it. Okay? So, now that I know it's an OR statement, I'm going to go ahead and split it, so it's going to be negative 3k minus 2 is greater than 2, or negative 3k minus 2 is less than negative 2. So now I just go ahead and solve it by adding 2 to both sides. I get negative 3k is greater than 4, or negative 3k is less than 0. Divide everything by negative 3. It's going to flip my signs. So I get k is less than negative 4/3, or k is greater than 0. Okay? So that's your answer. Alright. Now, what if, with equations we were very, very diligent about, if an absolute value equals a negative, that's not possible. But what if we have an inequality where it's either less than or greater than or equal to a negative sign? So, here we have the absolute value of 2x minus 3 is supposed to be less than 4. Well, ask yourself, can an absolute value be less than a negative number? Can the absolute value of the whole thing be less than negative 4? No, we can't have the absolute value be smaller than a negative number, because that just means it's going to be negative then. And the absolute value can't be negative. So, that means we have no solution here. But what if we had a greater than symbol? Okay? So we have the absolute value of 2x minus 3 is greater than negative 4. So again, we ask ourselves, can the absolute value be greater than a negative? Well, yeah, we can have any number greater than negative. Like 0 and beyond. All those positive numbers. We can't have like negative 1, 2, or 3, but it's not just limiting me to that. It's saying anything bigger than negative 4. So, yeah, it could. We just need to solve it to actually find out what x would have to be. Okay? So, just be mindful of that stuff. Alright, so our last our last one? Not our last one, sorry. So here, we're going to go ahead and solve and graph the following inequalities. So, first one, x minus 3m is a less than. So, what does that mean for ours? It means it's an and statement. Okay? So, I just combined them together and made it into negative 13 is less than or equal to x minus 3m, which is less than or equal to 13. If you did it as two separate, you would have the same thing. Okay? So I'm going to go ahead and divide or subtract 8 from everything. That's going to give me negative 21 is less than or equal to negative 3m, which is less than or equal to 5. Then divide everything by 3, or negative 3 rather. It's going to give me an ugly thing, but nonetheless, it works. 7 is greater than or equal to m, which is greater than or equal to negative 5/3. Now to graph this, okay, means I'm going to have closed circles on both 7 and negative 5/3, okay, which is about 1 and, yeah, almost negative 2, 1 and 2/3. So, here's what my graph would look like, okay? Because it's saying that m is smaller than the 7, okay? So, this one you might want to flip around so you have the smaller number in front, but you don't have to. Alright, B, same deal. I've got a greater than symbol, so I have an or statement, so I'm going to get 4r minus 4 is greater than 40, or 4r minus 4 is less than negative 40. So I go ahead and solve that by adding 4 to everything. I get 4r is greater than 44, or 4r is less than negative 36. Divide everything by 4. You get r is greater than 11, or r is less than negative 9. So you go ahead and graph that. There we go. And that's it. Alright, so this one, the try on your own. Yes, I gave you, like, the ugly one, I'm sorry. But it's x over 3 minus 2. The absolute value of that is greater than negative 7. Okay? And I kind of already gave you a hint. It's great for, or, and less than, and. Okay? So great for means an or statement, so you just go ahead and make up those, and then solve them. Okay? When you come back, I'll have the answer for you. Okay, so when you split it up, you should get x divided by 3 minus 2 is greater than or equal to negative 7. Or x divided by 3 minus 2 is less than or equal to positive 7. So you started with a negative here, so it's just the opposite sign, makes it positive. Ooh. Yeah, anyway. So I go ahead and add, I add 2 to both sides. I'm going to get x divided by 3 is greater than or equal to negative 5. X divided by 3 is less than or equal to 9. Then I multiply both sides by 3 to get rid of that divided by 3 part. And I end up getting something that doesn't want to show. Not close. Oh, this is really annoying. This is what I get. X is greater than or equal to negative 15, or something else that wants to be annoying. Or x is less than or equal to 27. Now, because it's an or statement, okay, to be smaller than negative 27 means I would go all the way to negative infinity here, but it also has, which I'd surpass anything below negative 15 then, and x would be greater than negative 15, meaning I'd surpass everything past 27, okay? So that actually means I would go in both directions, past our little stopping points, and I'd be pointing to everything, okay? So x is actually all real numbers. Anything I put in there would be greater than negative 7. I mean, think about it. The absolute value is greater than or equal to negative 7. I could put anything in there, and every absolute value would come out to be a positive number, which is always greater than negative 7. So that would work. Okay? Alright, so last one is try on our own. It's solve and graph it. So this one we're going to do together. This is your try on your own. So here, like I said with the equations that we did for our, what's it called? Exit ticket. You gotta get you must isolate the absolute value before you split anything in an equation or an inequality. So I'm gonna get the absolute value by itself by subtracting 5 from both sides. It's gonna give me 3 times the absolute value of 2x minus 1 is less than 9. Divide by 3 on both sides. You get the absolute value of 2x minus 1 is less than 3. Okay? Now I can split that to be 2x minus 1 is less than 3, and it's the less than symbol, 2x minus 1 is greater than negative 3. Add 1 to both sides for everything. You get 2x is less than 4 and 2x is greater than negative 2. Divide everything by 2. Comes out to be x is less than 2 and x is greater than or equal to or greater than negative 1. Now to graph that, you just go ahead and put an open circle on negative 1 and 2. Oops, wrong one. That's a different one. Ignore it. Make it go away. I can't. So we have a closed circle, or open circle on negative 1, an open circle on 2 that you can't see anymore, and they're connected because it's an and statement. Okay? Now go ahead and try this one on your own. When you're done, remember, don't forget to get the absolute value by itself. When you're done, I will show you the answer. Okay? Okay, so for this one, you should have gotten x is less than or equal to 2 and x is greater than or equal to 2, which is the red graph here. Okay? Please remember, if you have any questions, write them down on your notes page. I will be happy to answer them in class. But yeah, I will see you next class then. Have a great day. Bye. Oh, I did it again. I said bye before I got to the end of the recording. Okay, bye.